Hi there. In the previous video I explained the iterative method, and I went through an example showing you how the process works. Okay. In this video I'm going to continue from the previous video and go through another example. So here goes. So let me call this example number 2. Let me underline this. So the question being, use a suitable iterative formula. So use a suitable iterative formula to find a root for the equation, and the equation reads ln x plus x minus 4 is equal to 0 to 2 decimal places, so to 2 decimal places, okay, and we need to use x0 is equal to 2.5. So let's go through this example. Now, in the example in the previous video, the iterative equation was given to us. In this example over here, example 2, we need to form the iterative equation. So we need to create the iterative formula. Now remember, in the previous video, I gave you the steps in order to create your iterative formula. So let me go through those steps. So back to the current example. So in step number 1, let me underline this. So the equation that we have is ln x plus x minus 4 is equal to 0. Okay, and remember, in step 1, so let's read step 1. We're given fx equals 0. Okay, or if you don't have it in that form, it doesn't matter, because in the next step we need to do some rearrangement. But you're given an equation and fx is a function of x, and remember, x0 will be given, or you may need to come up with a value, okay, depending on where the root is lying. Okay, so over here in this example, the value of x0 is indeed given. X0 is 2.5. So step number 1 for me is collecting the data that you need, okay, from the question. Now in step number 2, if we go back quickly, rewrite the equation fx equals 0 in the form x on the left hand side, so only x on the left, and that's equal to a function on the right hand side. So if we go to the current example, I'm going to rewrite this equation so that I'm going to keep the x on the left hand side, so I'm referring to this x, and if I bring the remaining terms on the right hand side, I'm going to have 4 minus ln x on the right hand side. Okay, so that is step number 2. So remember, this equation is in the form x is equal to g of x. So let me write that in red to remind you, okay, as we've seen in step 2 of the method. Now in step number 3, x, replace that with xn plus 1, and all of the x terms on the right hand side, replace it with xn. So back to our example, step number 3, let me underline that. So I'm going to replace this x here by xn plus 1, and replace all of the x terms on the right by xn. So we're going to have 4 minus ln xn, and remember, x0 is 2.5. So as you can see, this is our iterative equation that we're going to use, and this is the value for x0. So if we go back to this question, remember, we need to calculate a root for this equation to 2 decimal places, and remember in the previous video, 2 decimal places is our desired degree of accuracy. Okay, so that is our desired degree of accuracy. That means that we stop the process when the consecutive values of x are the same to 2 decimal places. Okay, so let's start the process. So if I put x0 into this iterative equation, we're going to have x0 plus 1, which is x1, and that is equal to 4 minus ln x0. So x0 is 2.5. Okay, so if I replace that, I'll have 4 minus ln 2.5. Now remember in the previous video I recommended you to work out these values to a minimum of 6dp. Okay, so to a minimum of 6dp I had for this one 3.08, okay, 3710, so 3.08 3710 to 6dp minimum. Okay, so we don't have a value to compare it with, so if you compare it with x0, the previous value, it's not the same to 2 decimal places, so we need to continue. So if I put x1 back into the iterative equation, x1 plus 1, which is x2, so that is 4 minus ln x1. So remember, you can put the whole value back into the iterative equation to get the new value, or you can use your value to 6dp minimum and substitute that back into your iterative equation. So either way, I had a value to 6dp minimum of 2.83, whoops, not 2.83, 2.873, so 2.873,867. So I had 2.873,867 to 6dp minimum. Now if we compare x2 with the previous x1, x2 to 2dp is 2.87, x1 to 2dp 3.08, not the same, we continue. So if I put x2 back into the iterative equation, x2 plus 1 is x3, that is 4 minus ln x2, and I worked this out, and to 6dp minimum for x3 I had 2.944342. Let's make a quick comparison. To 2dp, x3 is 2.94, to 2dp, x2 is 2.87, not the same to 2dp, so we continue. So if I put x3 back into the iterative equation, x3 plus 1, which is x4, that is 4 minus ln x3, and to 6dp minimum x4 I had 2.920115. Okay, so if we make a comparison to 2dp, x4 2.92, x3 2.94, not the same, we continue. So if I put x4 back into the iterative equation, x4 plus 1, which is x5, that's 4 minus ln x4, and to 6dp minimum I had 2.928377. Okay, let's make a comparison. x5 to 2dp 2.93, x4 to 2dp 2.92, not the same, close but not the same. Unfortunately we need to continue. Okay, so we're nearly there. If we put x5 back into the iterative equation, x5 plus 1, that is x6, that's 4 minus ln x5, okay, and to 6dp I had 2.92, okay, 5552. So let's make a check. So to 2dp 2.93, the previous value x5 to 2dp 2.93 as well. These two values are the same to 2dp, so these two consecutive values same to 2dp. Now we stop, okay? So 2.93 to 2dp, 2.93 to 2dp, okay? So just to conclude, solution for the root x will be 2.93 to 2 decimal places, our desired degree of accuracy, okay? So that completes this example, and here are the steps involved in order to solve such a question, okay? That also ends the video, so I hope you found this video helpful. Do related practice questions, and I hope to see you in the next video. Thank you.